Today we're looking at parallel lines and the special relationship that forms around these parallel lines. So right up the top there you can see a set of parallel lines. Now remember, parallel lines will never ever meet. Think of tram tracks. It's two straight lines that are going in exactly the same direction. The line that cuts those parallel lines is called a transversal. And so when you've got this transversal, which is a straight line cutting parallel lines, we're going to explore some of the relationships that are happening here. Firstly, looking at corresponding angles. Now, corresponding angles are in exactly the same spot on the same side of the parallel lines and on exactly the same side of the transversal. So if you're looking at the example in front of you, those two angles are equal, as are these two and these two. They're also corresponding. These two and these two would be corresponding, and the last set of corresponding would be these two and these two. Remember, they are all equal. Alternate angles are also equal, but let's focus in on these now. You can see that they're both inside the parallel line and on opposite sides of the transversal. And often with alternate angles, we tend to say that they form a Z. Can you see that Z that I'm forming there? All right, we can do another Z the other way as well, which would go like that. Sorry, like that. So that one and that one would also be alternate angles. Again, alternate angles are equal. Co-interior angles, also inside the parallel lines, but you can see that they are on the same side of the transversal, and in actual fact, they do add up to 180 degrees. Two angles that add up to 180 degrees we call supplementary angles. So also this one and this one, both inside the parallel lines on the same side of the transversal, they add up to 180 degrees. They are co-interior. Let's look at some examples here. So the question says, find the value of the pronumerals in this diagram and write down the reasons for each. I think perhaps the easiest one to look at to start with is this 150 degrees with the C. We should be able to remember that these are corresponding angles. So C is equal to 150 degrees because it is corresponding to what? To the 150 degrees. A plus C should equal 180 degrees because they are co-interior. Well, we already know that C is equal to 150, therefore A must be equal to 30 degrees because it is co-interior. There could be other reasons, there's more than one reason why. A and B, can you see that Z happening there? They are alternate. So we already know that alternate angles equal each other. So if A is 30 degrees, then B is also equal to 30 degrees. It is alternate to A. Last one to find now is D. Hopefully you can see that D is co-interior. See that C? It's a backward C, but it is co-interior with B. And we know that co-interior angles add up to 180 degrees. Now if B is equal to 30, then D must be equal to 150 degrees. Hopefully you can see it's a bit of a domino effect. Just because I've done them in that order doesn't mean that you have to, but you could do it in slightly different ways and still end up with the same answer. The next example is fairly interesting. The question says, decide with reasons whether the given pairs of lines are parallel. Now we've just gone through all the different relationships in parallel lines. And if you look at those two angles there, you should be able to see that they are alternate. And what do we know about alternate angles? They have to be the same. So because they are both 120 degrees, then we know that those lines are parallel. If one of those angles had been different to the other one, then they would not have been parallel lines and therefore not alternate. So they are parallel lines. And why? Because they are alternate angles. They follow the rules from the previous page. Looking at this example, so we're still looking to see whether these are parallel lines. I guess by looking at it, you'd probably say they're not because they don't look like they're parallel, but how would we prove that? Well, those two angles, if they were parallel lines, would be considered co-interior. And we know that co-interior angles add up to 180 degrees. So the question is, 120 plus 50, does that equal 180? No, it doesn't. It equals 170 degrees. So therefore, they're not co-interior, and therefore the lines are not parallel. This last example, where it asks you to find the value of x, looks really interesting, doesn't it? At first sight, it doesn't really look like we've got parallel lines there, but those two arrows that you see on both of those lines mean they are parallel. So I can actually extend that out like that. So there's our parallel lines, and the transversal is this line here, which I'm extending in green. So you've got two parallel lines with the transversal going down, and hopefully what you can see here is that you are dealing now with an angle on the same side of the parallel line, on the same side of the transversal, so they are corresponding angles. And what do we know about corresponding angles? We know that they are equal. So x is equal to 20 degrees.